Hello everyone, welcome to my channel Indian School of Physics. This is Nitin here, and today again I have come up with a very interesting problem. It's a very simple yet interesting one, and by the way, it is an original problem. It was framed by me. So let's discuss the statement of this problem. It looks very scary, but actually it's a very simple problem. So here is the statement of this particular problem. So, two liquid drops having radius R1 and R2 are placed in a gravity-free space. The liquids are having densities D1 and D2, while they have same surface tensions. When a gentle push is given to both the liquid drops, they start oscillating into an ellipsoid shape, as shown in the figure, and regain the spherical shape due to surface tension. The time after which both the drops regain the spherical shape is given by T1 and T2 respectively. Then the value of T1 by T2 will be. Now, so after looking at this question, most likely majority of the students don't get any idea. I gave this question to my students, and only two of them have solved it successfully. Almost out of 300 students, 2 students have got the right answer for this question. So you can understand, like, it's a look stuff, but it's very simple. So I'll give you the idea. See here, if we try to solve it by normal method where we can derive the expression of this surface tension, then surface tension and time period, then it is going to be a very lengthy problem. But however, since in the question they are asking the ratio, so the common part like surface tension and the proportionality constant of the formula will not depend on this ratio. The ratio will be independent of those quantities. So definitely here I can take the luxury. I can use a method or a tool which is very handy in JEE problems, especially very frequently questions have come. So here we are going to use dimensional analysis. We'll try to solve this question using dimensional analysis. So let's discuss this problem. Here you can say the concept wise, the time period will depend on these three quantities. One is surface tension, one is density, and one is the radius of it. No other quantity is given, so most likely the dependency of time period will be on these three quantities only. So I can simply write here that this time period, it must be proportional to surface tension to the power A, and density to the power B, and radius R to the power C. We are going to calculate this A, B, C values here. All right. So now I can write dimensions of density, which is mass by volume, so ml to the power minus 3. Similarly, I can write the dimension of this surface tension, which is force per unit length dimensionally, you can say. So force dimensions are mlt to the power minus 2 divided by L. So dimensions of surface tension is also known to us mt to the power minus 2. When I substitute these dimensions here, for R it is length. When I am going to substitute these values in this expression, I am going to get T is proportional to mt to the power minus 2 to the power A, ml to the power minus 3 to the power B, and this radius R, which is length to the power C. So when I try to combine these terms, I'll be getting this time period will be proportional to m to the power a plus b, L to the power c minus 3b, and similarly I can write t to the power minus 2a. So from here I can say other side there is no dimensions of m and L, so definitely a plus b should be 0, and this c minus 3b also should be 0, and this minus 2a must be equal to 1. Alright, so that is what I am writing here. A plus b is 0, c minus 3b is 0, and minus 2a is equal to 1 in this case I am writing. Alright, so a value straight away I'll get, that is minus half. Then I substitute here, I am going to get b as plus half, and when I substitute this value of b here, I am going to get c is equal to plus 3 by 2. So immediately I'll know the values of these. When I substitute these values here, I am going to get this expression of time period as it must be proportional to rho to the power 1 by 2 r to the power 3 by 2 and surface tension to the power 1 by 2. All right, so here when I take the ratio of T1 by T2, it will become rho 1 by rho 2 to the power 1 by 2, r1 by r2 to the power 3 by 2, and gamma 2 by gamma 1 to the power 1 by 2. But since gamma 2 and gamma 1 are given equal, the two liquid drops are having same material, same liquid drops. So we can say this dependency will be only on density as well as radius r. So this is going to be the right answer here, and that is T1 by T2 is equal to rho 1 by rho 2 or d1 by d2 to the power 1 by 2, r1 by r2 to the power 3 by 2. This is going to be the final answer for this question. I hope you have enjoyed this method of solving. However, it will be quite challenging if we try to solve this question by finding actual time period and then taking the ratio of it. And this method of dimensional analysis is very, very important as far as JEE Advanced is concerned. In the past also, sometimes in the questions they have given options in such a way that where one of the option can be eliminated and you can reach to the right answer quickly. So if you have enjoyed this video, if you have learned something meaningful with the help of this question, then please give a like, share it with other friends and teachers. And if you haven't subscribed my channel, please subscribe it. I'll be bringing another amazing problem very soon. Thank you very much.